In this video, we're going to see how to find any trig ratio of a special angle with no calculator. So let's take this example. So we're going to actually divide it into three parts. The first part is just figuring out where the angles lie in the Cartesian grid. So we're going to look at 5 pi over 4. We remember that we always take the angle with respect to the positive x-axis. So 0 degrees is here, and then this would be 0 radian, and this would be pi radian. We're working radian today. So to locate, so to locate 5 pi over 4, the numerator is bigger than the denominator, so I know that I have at least 1 pi in there. 4 goes into pi once, and then I'm left with a quarter. So essentially 5 quarters is 1 1/4. So that would mean pi plus a quarter of pi. So full pi we get to here, and then a quarter of pi. So again, the next a pi radian if we divide it into 4 equal parts. So 1, 2, 3, 4 equal parts. If I'm going 1/4 of that, I'm exactly here. Okay, so our terminal arm would be over here. So this angle here is 5 pi over 4. And if I look at the acute angle with respect to the x-axis, this is pi over 4. We'll do the same thought process with the other angles. So 11 pi over 6, where would that be? So 11 sixths is 1 1/6. So 1 pi. And then if I divide the other pi that's left here in 6 equal parts. So 1, 2, 3, 4, 5, 6 equal parts. I'm at, not 5, 6, but 1/6. So, sorry, no, this is 5, 6. 1 5/6. So I'm going to go all the way over here. So this angle here is 11 pi over 6, or 1 5/6 pi if we look at it that way, which means we're looking at this acute angle of pi over 6. Finally, for our last angle, so 5 pi over 3, we're going to take a look at this one. So that's 1 pi radian plus 2/3. So if I divide this into 3 equal parts, look maybe something like this, and then I will continue 2/3 of those parts. So 5 pi over 3 would be this angle. Sorry about the ads popping up. So this angle, which means my acute angle will be pi over 3. Okay, so with respect to the x-axis. So now what we need to do is just create our triangles. So I'm just going to pull this back. You always pull it back to touch the x-axis so that your 90-degree angle is over here. So we'll do the same with the other two. So if we recall one of our two special triangles, it is the isosceles triangle with degrees of pi over 4. So you should recognize that as being the same triangle here. So because we know the side length of this triangle to be square root of 2 over 2, which we found with the Pythagorean theorem, then we know that the length of this is also square root of 2 over 2. It's the same triangle. So what we want to do is write not the length of the sides of the triangle, but the coordinates of this point. So because I'm to the left of the y-axis, that means that my x value should be negative. So I'm going to have minus square root of 2 over 2, which represents this over here. And then for the y-axis, or the y-coordinate, we also have, it's below the x-axis. So we'll have to have also a negative value because we're down here. So now we're ready to evaluate the trig ratio. So cotangent of 5 pi over 4 is the reciprocal of sine. So you'll have cos over sine. And we remember that the coordinates in the unit circle are the cosine and sine respectively. So this will evaluate to 1. For the other two triangles, they have radian of pi over 6 and pi over 3. So we use this, this special triangle. you can see that it has a long side and a short side. So the long side would be square root of 3 over 2. So that's my x value. And the short side is 1/2. So because I'm below the x-axis, it has to be negative. So we have the coordinates of this point. Therefore, we can find the tangent. So our second trig ratio. So we'll just do the tangent is equal to sine over cosine. So sine is my y value minus 1/2 divided by cosine, which is my x value. So square root of 3 over 2. So when we divide, we'll multiply by the reciprocal, and we're left with minus 1 over square root of 3. You could rationalize this or leave it like this. I will just leave it like this. We'll do the same thing for the last ratio. So it's the same triangle, but positioned differently. So we get our x and y coordinates. So same thing again, y is my sine value, so square root of 3 over 2 divided by cosine, which is 1/2. So if we multiply by the reciprocal, we get minus square root of 3 for tangent of 5 pi over 3. So for our final answer to evaluate this to its exact value, so we'll have 1 coming from here plus minus 1 over square root of 3 times minus square root of 3, which ends up giving us 1. Minus 1 times minus 1 is 1, so we'll get 1 plus 1, which is equal to 2, which is our final answer.